So you will be able to use a reference sheet that has some formulas on it, and you can see exactly which formulas if you look at that green sheet. Otherwise, I'll have another smaller one that just has that stuff on it for you on Monday. Today so this is the formulas you need. Everybody find them, or gonna wait for Monday's copy. But yesterday we did arithmetic, so we talked about this formula. They put the D at the back, but yeah, come on, cursor. We did this one yesterday for arithmetic. We have not done sums yet, okay? On the reference sheet will not be listed. This is explicit, okay? That one's there, but recursive will not be listed. Does anybody remember how recursive went yesterday? Plus something, right? And then you also have to tell me what the first term is, okay? That recursive business is not on there because that's pretty basic. You should, if you know what recursive means, you should be able to put it down, okay? Today we're going to talk about geometric. So a geometric sequence is a series of numbers, okay, or terms generated by multiplying. What are you looking for? Oh, wait a minute. I got it for you yesterday. I forgot you. Here you go. I think that's all yours. Is that right? Terms generated by multiplying by a common ratio. So we're going to call that R, what you multiply by. So let's make up an easy one. 2 times 3 is 6, times 3 is 18, times 3 is maybe 54, times 3 is maybe something bigger than that. Okay, so R equals 3 here. That's an example of a geometric sequence. So to find R, I'm going to write this down, but this is just a lot of notation. You take any term and divide by the previous term, where n has to be greater than or equal to 2. That's crazy business. If you want to know, you just pick any term and you divide it by the one before. So 6 divided by 2, or 18 divided by 6, or 54 divided by 18. They all should turn out 3 if it's geometric and R is 3. Making sense? Okay, this is just a fancy schmancy way of writing it. Okay, R can be negative. What will you notice if R is negative? Will every term be negative?
No,
It'd be every other one would be negative, right? Because if you multiply by a negative, it's going to go negative, positive, negative, positive. R can also be a decimal or fraction, less than 1. It can make it get smaller and smaller. All right, so explicit form, remember, means it's based on the term number. So there's going to be an n left in the equation. So a sub n equals, how are we going to have to start? You still have to know the first term, right? And then, are we adding? We're multiplying, and it's not a difference anymore. What did we call it just a second ago? R for ratio. Now, when you added, remember you were adding d minus 1 times, or n minus 1 times, I'm sorry, right? How do we say we're going to multiply by something n minus 1 times? How do you say you multiply by something 3 times? You cube it. So where are we going to put n minus 1? Okay, that formula is on your sheet. Don't have to memorize it, but it should kind of make sense that you take the first term and you multiply it by the r, or the ratio, n minus 1 times. Now, I would suggest you practice with parentheses here, because if r is negative or a fraction, you have to be real sure that you use the parentheses. So it's good to put it in parentheses. So our example a minute ago was, we started with 2 and then we multiplied by 3, right? 6, 18, 54. Is that what it was? Okay. So how would we write that in explicit form? A sub n equals yes, explicit means you leave the n in. Now, huge question. Please don't miss this. Can you do 2 times 3 is 6? No. Okay, so don't do that ever. Leave it like this. Yeah, Haley, this is for you, huh? All right, recursive is the same idea. You tell me the next term based on the previous term. So what are we going to do to the previous term always if it's geometric? Okay, that's okay. If it's a geometric sequence, you are always doing what to get the next term? Multiplying. So you take the previous term, whatever that was, and you do what? You take the term, to get the next one, you take the one before it and multiply. Yeah, if you were going backwards, you would divide. I gotcha. Okay. And remember, when it's recursive, you always have to tell me where it started. So our example again, 2 times 3 times 3 times 3. Okay, how would you write that as a recursive sequence? A sub n minus 1, the term before it. And then you would say where a sub 1 was 2. Remember, I'm okay if you put the a sub 1 out front, because that's how I think of it. Starting at 2, I'm multiplying by 3. But in the book, they will list it like this. They always put it at the back. Yes? It is here. You always have to tell me what the first term is. Okay? So, guys, Kayvon wasn't here yesterday. What are the words you say when you see this notation? If this was the 5th term, this would be the 4th term, right? So it's just the previous term. Is that word okay? I use that word all the time. Does everybody understand what that means? Just means the term right before it? Yeah, I understand. Okay. Okay, no, you're good. I just want to make sure that word previous wasn't messing anybody up. It is so stuffy in here today. I'm roasted. Okay, determine this if the sequence is geometric. If it is, find the common ratio. So it looks to me like this would be multiplying by a negative, right? Because it goes negative, positive, negative, positive. Again, we would do 8 over negative 16, or negative 4 over 8, or 2 over negative 4. Are those giving us the same ratio every time? Yeah, they all reduce to, so it's yes, where r is negative 1/2. Is it possible for a sequence to be negative, 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 negative? Yeah, if what you're multiplying by is positive, right? And you start with a negative, does that make sense? But let's see if that works. Negative 10 over negative 20, that would just be a half, right? Yeah. I don't think this is going to work, is it? Negative 20/3 divided by negative 10 would be 2/3, I think. Is anybody typing that? Yeah. Okay. And negative 5 divided by negative 20/3, b times 3/4 maybe? Is that what that one came out?
Yeah, no.
Yeah, it's just a no. Okay, so the R is this, and then it's this, and then it's this. It's kind of a cool pattern. We could probably continue it, right? Could we multiply by, let's see, 1 over 2, 2 over 3, 3 over 4, 4 over 5, and find some kind of a pattern, but okay, you're confused about what I did and why?
Oh no, I was just divided by.
To find the ratio, yes. If you're trying to determine if it's geometric, Kayvon, this is where I tried to write it, but I should write it in words. You take any term and you divide it by the previous term
Okay.
to get the ratio. That help?
Yeah.
Because I just wrote the symbols and forgot you weren't here, didn't. All right, so these, it says find the common ratio, so they must be geometric. So luckily we don't have to test all of them necessarily. And then find the next 3 terms. So can you tell what they're multiplying without doing anything crazy? Yeah, if you look at the top, it's multiplying by 2 and the bottom is multiplying by 3. So I'm thinking R is 2/3. Or you could take any term, divide it by the previous term. If you did this, you'd get the same R. Okay, so however you want to find it, we got it. Now how do we find the next 3 terms? Yeah, keep multiplying the top by 2. So I'd get 32, and then 64, and then 128. How did I do? And on the bottom, multiply by 3, 81, 243, 7, 26, 29. Yep. I don't think any of those reduce. I'm going with no. That was kind of icky. Glad they only asked us for 3 terms. I think I'd be lost after that in my head. Okay, what about this one? What's R? Everybody okay with that? 4 divided by -1. So the next 3 terms, I don't know, 256 maybe, negative? Then I need help. 1024?
Yeah.
496, 4096. I'm gonna need help today because this by the end of the day, my little brain's gonna be okay. Given the explicit formula, so this is an explicit formula, which means if I wanted the 7th term, how would I find it, guys? Put in a 7. That's it. Explicit formula means you put in the term number. Find the common ratio in the first 4 terms. Well, let's find the first 4 terms the hard way kind of this time. Let's figure out by putting in a 1. So a sub 1 would be 2 times 6 to the 1 minus 1. I just want you to have this in your notes so you understand you can always do this. Most of us would figure it out faster than this. You don't have to write that down if you don't want to. Yes. Yes. All right. Now, can I do 2 times 6 first?
No.
No. So this becomes 2 times 6 to the 0 is really 1, right? This is 2 times 6 to the first. This is 2 times 6 squared. And this is 2 times 6 cubed. So the actual sequence would go 2, 12, 72, help, 432. That's too big, isn't it? Did we have to do 4 terms? We did. Okay. All right. Also the question was, what is R? What did we have to keep multiplying by? 6. Okay, so here's my question. Could we have picked the 6 out of the equation and figured out that's what we were multiplying by? The way this one is written, absolutely. Could we have picked out the first term? Yes, the way this one is written, we certainly could have. Be careful. You can't always, because they can write some pretty funky explicit formulas. Okay, but I think this one we're good on. What's R and what's the first term? So R is just -4. So the first term, if we put in a 1 here, this would be 0 times, so we'd end up with -4 to the 0 power is just +1, right?
Yeah.
So -0.25 would be the first term. Okay. Then we got to multiply by -4. We'd get 1, right? Then we multiply by -4, get -4. Then we multiply by -4 and get 16. Whew, that one wasn't as bad as it looked. Okay, I want to show you something. We're going to do this in a second anyway, but if you wanted to find like the 12th term here, okay, can you try that? Yep, just put in 12. I'm just worried that you got to type this very carefully. You have to have those parentheses. 0.25 -4. Okay, thanks. Yep, there's a negative both places. I forgot. To the 12 minus 1 or 11th power. A million something, okay? Just be real careful, because if you left out the parentheses, would you get the same answer? I just made that a times. Okay. Well, you don't want to know why? This is a bad example. If I change that to 13 minus 1, okay, you get this. But if I put those parentheses back in when it's odd, okay, if the exponent turns out to be even, that's what's going to mess it up. Anyway, just use the parentheses. That was a bad example, Hofbauer. All right. Sometimes you need the parentheses. I would just use them always. Okay. Given the recursive formula for geometric, find the common ratio in the first 4 terms. All right. Easy peasy. What's the first term? 108. And what are we multiplying by? So R is 1/6. So if we do this times 1/6, oh, I'm going to need help. 18, 3, and 1/2, I think. Yes? And you could do a decimal for that. Just be careful. It wants exact answers, guys. So if you get a crazy decimal, just do math, enter, enter, and use fractions, okay? Don't use rounded decimals ever. All right, find the common ratio in the 8th term. The common ratio would be 8 over -2 or -4. So how can we find the 8th term? A sub 8 would be the first term of -2 times the ratio of -4. How many times? Yeah, or 7 times. So -2 times -4 to the 7th. We could leave off the first parentheses if you want. $32, 7, 6, 3, 2, 7, 6, 8. Anybody? Is Keaton the only one gone? Okay. Write the explicit formula. Somebody else got this one? Nolan? Good. R is always any term divided by the previous term. So 1 divided by 3, which is what they multiplied again. You can check anywhere. All right. Given the recursive, find the explicit. Go ahead, Kayvon. Okay. Can I skip 15? Just make sure you're using the parentheses, okay? Just always use the parentheses around R and you'll be safe. Okay, find the recursive. Remember, recursive is where you go a sub n equals a sub n minus 1, then tell me how to get to the next one, and you got to tell me the first one. So 16, who's got this one? Where? That's how I always say it to myself, where a sub 1 was also 3, yes. So if you were writing the explicit for this one, it would be 3 times 3 to the n minus 1. Could you simplify that?
Oh, no.
This is 3 to the 1 times 3 to the n minus 1. When you have the same base, what can you do with the exponents? What is x squared times x to the 7th? You add them, right? So this could also be, this is an explicit formula for this. 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, okay? This is the kind where I'm telling you, if you want to know the first term, you got to put in a 1. The second term, you got to put in a 2. Be careful because they will write it in different ways than we're used to for explicit form. No, you could leave it like this and I'd be fine with it. But it didn't ask explicit anyway for this question, okay? That was extra information. All right, who's got this one quick then? A sub n equals times, okay, I would probably put parentheses just because if you write times minus 2, it looks like a negative or something, you know what you're not subtracting, so make sure. And the first term is 3, you got to have that. Are we good? All right, find the recursive. Well, can you tell what a sub 1 is? You could put in a 1 if you needed to on your calculator. This would turn out to be negative 5 to the 0, which would be 1, so you'd end up with 0.4. Okay, and what are they multiplying by over and over?
5.
So how would we write, sorry, I even put parentheses there. How would we write it as a recursive? We'd say a sub n equal where a sub 1 is 0.4. By the way, I don't know if I mentioned in this class, but they will also write things like n has to be greater than or equal to 1. You can't put in a negative term number. So if you see these little inequalities, they're just like extra information, okay? Don't let it freak you out. I don't require them, okay? Do we need to do the next one? Are you good? Good on 19? Okay. 20, find the term named and the explicit formula. Well, let's start with the explicit formula. What's the first term? Okay, so a sub n equals 3 over 2 times, can you tell what they're multiplying by? Yeah, 1 on the top, 2 on the bottom, right? So there's the explicit form. So what can we do to find the 11th term? Yeah, put in 11, or do 3 halves times 1 half, 11 minus 1, or 10 times. Fraction would be good here. I'm getting 3 over 2048. I actually did this in my head. I did so then I did that on my calculator, but it doesn't matter. That was just my brain. Worked anyway. Everybody got it? All right. Need to do another one? Let's do it just because it's negative. So the first term is negative 1.5. You can put it in parentheses if you want, but the ratio needs to be in parentheses. What is the ratio? You got to be careful. 3 divided by negative 1.5 is negative 2 is the ratio. So put in an 11. All right, let's make sure we get the sign right. So negative 1.5, parenthesis, negative 2 to the 10th, or 11 minus 1 is fine. Everybody okay? How are we doing? We almost done? Okay. First term, fourth term, find the 11th term, and an explicit formula. So what's missing? Okay, this is where it gets a little tricky. So I'm going to write it this way. I'm going to say the first term is 3, second term, don't know, third term, don't know, fourth term is 24. That helps some of you see what's going on. So to get here, we would multiply by r, whatever r is, right? Then we'd have to multiply by r what? Again. And then we'd have to multiply by r again. So the difference in these numbers tells you how many times you were multiplying by r. So it's 3 times r to the third gave us 24. How do we solve that? Divide first. Got to do your algebra 1 first. Now, I know you guys know the cubed root of that in your head, but does anybody remember if that said like the 5th root or the 7th root, what is the fastest way to do that on your calculator? The fastest way to do that is to the, yes, thank you so much. The fastest way to do this is do 8 to the 1/3 power. You don't need parentheses because if you got the little box up there anyway. So you should get 2. Everybody was good with that? I say that because we're going to have somewhere you have to take like the 1/7 root. And there is a way to do it on here under the math thing, but it's so much faster if you just do to the 1/7 power. All right. So what did we just find? We found r. Now we have to write an explicit formula. So then to find the 11th term, we'd have 3 times 2 to the 10th. I got 3072. Did anybody get that? Okay, kind of hoping there's another one like this. Is there another one like this?
Yeah.
Ooh, yeah. Fractions and negatives. Okay, so we don't know the first term, but we know the second term. Then there was a third term, a fourth term, and we got to this fifth term. It just helps me write it out. You don't have to. To get to this term, how many times did we multiply? The difference between here and here was 3. So negative 4/3 was multiplied by r 3 times and became 4/81. Divide first. 4/81 divided by negative 4/3, or times the reciprocal. Is it negative 1/27th maybe? Okay, and then if we do to the negative, or to the 1/3 power, or take the cubed root. Why won't it let me go down? R equals negative 1/27th to the 1/3 power. You get negative 1/3, okay? Explicit formula. Christian, can you tell me? Oh, what do we not know? Okay. So normally, this first term was multiplied by negative 1/3 and became negative 4/3, right? So negative 4/3 divided by negative 1/3? I think positive 4. Now, Christian, can you tell me the formula? A sub n equals okay. The explicit formula says a sub n equals a sub 1 times r to the n minus 1. So we're going to put out here a 4. That's it. Make sure you have parentheses. And then to find the 12th term, we're going to put in a 12 up here. So 4 parenthesis negative 1 divided by 3 close parenthesis to the 11th power, or 12 minus 1. Woo, got a mess. Did it change it to, uh-oh. Okay, this would be where the rubber hits the road, as my mom would always say. We got to figure this out without the calculator. Okay, because the calculator wants to give us a decimal, and it's not exact. It's 4 times. Okay, what, we're doing 12 here? Oh, it's 12 minus 1, right? Okay. So it's 4 times. And it's really, guys, negative 1 to the 11th. Oh my goodness, that's not negative 1 to the 11th. Let's do this. Negative 1 to the 11th over 3 to the 11th. Okay. What's negative 1 to the 11th?
Negative.
Okay. And what's 3 to the 11th? Did I hear you right? Okay. So what's that going to be? 4 times negative 1 is just negative 4, right? Over 177,147. Okay. Type that decimal and see if you get the same one. Negative 4 divided by 177,147. Same decimal, right? Okay. I don't think I put one on the quiz where your calculator wouldn't do it, or at least where my calculators wouldn't put it back to a fraction, okay? One more, you said? This is the last one? Okay. So your homework is to do the stuff on 4AB that's circled. Find the 11th term. Oh, this is weird. Why did they state it in this order? We know the first term, right? 1.5. Second term, third term, fourth term is 12. So how many times did we multiply by r? 1, 2, 3 times. So 12 divided by 1.5, I don't know what that is, 9, 8? And then 8 to the 1/3 is 2. So if we had to fill this in, times 2 would be 3, times 2 would be 6, times 2 would be 12. It's working, right?
Yeah.
But we want the 11th term. So a sub n equals, the explicit formula would be 1.5 times 2 to the n minus 1, and we're going to put a 11 minus 1 or 10 up there. 1.5 times 2 to the 10th. 1536, anybody? Okay, take out worksheet 4 and get started. You got time. Do the circled ones. Maybe start with the hard ones. What do you think? You only have to do the circled ones. Do more if you want. But maybe go to the back of it and start with the hard ones.